In this lesson, we're going to take a look at a new type of graphing called polar graphing. Now, you're familiar with rectangular coordinate systems, where we locate a point using its x and y axis location. And we might have a point over here at 4, 3. So that's pretty old stuff. Well, now we want to locate a point like this in a different way. And we're going to talk about rotating an angle and finding a distance here. And we graph that like this. We're going to have a point called a pole, and we're going to have a polar axis, and we're going to rotate an angle theta, and we're going to travel out a distance r. And the location of this point here is determined by those two characteristics, those two coordinates. We have the radius, how far out we're traveling from this pole, and this angle here, theta, is how you rotate it. So let's see how we can use this. We'll begin by graphing some points. Right here we have a polar coordinate system. Here is our polar axis right here. It's not always labeled or drawn in. If you'd like, you can. Okay. We're going to find a point now by rotating an angle and finding the radius. Here we have circles that have the same center. We call those concentric circles. And so we have a radius of 1, 2, 3, 4, 5. So we'll go ahead and label this 5 out here. Okay. So now if we want the point 2 pi over 4, that means we need to go out 2 units and rotate pi over 4. Now if you look carefully here, each of these are 15 degrees because we have 1, 2, 3, 4, 5, 6 that make 90 degrees. And 90 divided by 6 is 15. So each of these are 15. So the point 2 pi over 4 is going to be right here. That is our point P. You can think of it in any order you want. You can either travel out and then rotate the angle, or you can think about rotating up to an angle and then traveling out. In fact, thinking of the angle first is going to be often useful. Q is at 3, negative 45. So we're going to go out to 3, and we're going to go down to negative 45 degrees. Okay. So we have negative 45 here, and we'll be right out here. Okay. This was positive 45 here. Now we're going to travel for, that was Q. For R now, we can have a negative radius and a positive angle. Okay. And to do that, we're going to go first to our angle. So we're going to rotate around to here. This is our pi over 6 line here. And so we'll go ahead and label this pi over 6. So if we rotate to that line, if we travel outward to the right, that's going to be our positive direction. So if we rotate and travel forward, that's going to be a positive direction. If we want to go backwards, that's going to be a negative direction. So to get negative 4, we're going to go up to pi over 6, and we're going to travel back 4 units, and we'll be right back here. And so we'll plot this point at right there. Try that again. Okay, there we go. And that would be the point R. Okay. Let's try one more. Let's try negative 3 and 3 pi over 4. So we're going to rotate around to 3 pi over 4. That's this line right here. So we have our line 3 pi over 4. And then again, we're going to travel in a negative direction. So if we rotate around this way, positive would be going forward after we rotate. Negative would be going backwards here. So if we start from the pole here, or where the origin would be, we rotate and then we travel back 3 units, 1, 2, 3, and we end up right here where Q is. So we see, that's kind of interesting, that Q and S are in the same spot. So there's more than one way to describe the same point. So B and D here, or points Q and S, are the same. Okay? So we can think about this. Let's find two other polar coordinates for this point, 2 and negative pi over 3. So let's first find 2 and negative pi over 3. Negative pi over 3 is negative 60 degrees. And we're going to travel 2, so we're going to rotate down to negative 60 degrees, and we're going to go out 2. Once again, it's often useful to think of the angle first and then find that point. So here's the point we're talking about. We'll call this P prime because we already had a P there. How about that? Okay. Well, what's another way to find that? We could talk about the positive angle that wraps all the way around. Okay, and that positive angle would be 2 pi minus pi over 3. So that would be 5 pi over 3. So we could call it 5 pi over 3. And we have a radius of 2. That's one way to go. We could talk about this in degrees if we wanted. 2 and negative 60 degrees. We could also travel in a positive angle, and we could move backwards. Okay, so let's go this angle right here. Let's do this in a done. Okay, so this angle right here continues on. Okay. And so we can see that this angle right here is 2 pi over 3, 120 degrees. And so we can go 2 pi, oops, that would be our angle, 2 pi over 3, and we would go backwards 2. All right? So that's the idea. You can think about it, if I was standing here, I could turn and go backwards. Turn, I'd be facing this way, and then I'd walk backwards to end up over here. That's the idea. And the last thing we want to look at is going back and forth between polar coordinates and rectangular coordinates. So we just found out this generalizes what we just found out, that we can, if we have a point at r theta, we can go around any multiple of 2 pi and be at a positive radius, or we can go around half a circle and go backwards. Well, what if we want to locate a point in a different coordinate system? So here we have a point 3 pi over 6. And we want to find out what is the Cartesian coordinates of this. Well, it looks like, what is that? Maybe 2, this is 4, so that's 3, so maybe 2.5 or something like that, and 1.5. Well, it all boils down to our trigonometry. So if we come down, this is our x, this is our y. We know that the radius is 3, and this is pi over 6. And that should look pretty familiar. We know that the cosine of x, I'll make that the cosine of pi over 6, that's our angle. Pi over 6 is x over 3. So that gives us x is 6 times the cosine, 3 times the cosine of pi over 6. We know that the sine of pi over 6 is y over 3. And so that gives us, let's clean this up a bit. And so that gives us y is equal to 3 sine pi over 6. All right, and we know what those are exactly. So in this case, this is 3 times the cosine, which is root 2 or 3 over 2. And so we have 3 root 3 over 2. And the sine of pi over 6 is a half. So this is 3 halves. So our final answer is the Cartesian coordinates, or the rectangular coordinates, are 3 root 3 over 2 and 3 halves. So in polar coordinates, we have 3 pi over 6. In Cartesian coordinates, we have 3 root 3 over 2 and 3 halves. That would be our x and our y. And if we want to go the other way around now, here we have a point, and in rectangular coordinates, this is 3, 4. We want to figure out what it would be in polar coordinates. So we need to know what this angle is and what the radius is. Again, we're just going to boil down to some good old trigonometry here. So let's think about a right triangle. We know this is 3, we know this is 4. With some Pythagorean theorem, we know r squared equals 3 squared plus 4 squared. So r is the square root of 3 squared plus 4 squared, which comes out to be 5. And last but not least, we know that the tangent of theta is 4 over 3, or we can say theta is the inverse tangent of 4 over 3, which comes out to be approximately 55.1 degrees. Okay, so to generalize it here, we can see, well, the radius was just the square root of x squared plus y squared. That was easy stuff. We can see that the tangent of theta is just y over x. Okay? All right, so that converts from Cartesian coordinates to polar coordinates. Okay, the other way around. So this is from Cartesian to polar. If we're going from polar to Cartesian, well, the x coordinate is r cosine theta, and the y coordinate is r sine theta, which should look pretty familiar from what we've been doing with vectors if you've been following along. So, and here those formulas are right down here for you. So that's how we find points in the polar coordinate system, and so give that a try and see what you can do.